Recording in progress.
Okay, so let's go over the homework, guys. So what are you supposed to do about 754 from homework number 20? And what I'll do is I'll take screenshots of these so that I can save these and put them in Schoology. So all you have to do to find the coordinates of the points on a unit circle, because this is a unit circle. Remember, unit circle radius is 1, center is 0, 0. Okay, so for point P, you're going to do this. You're going to say cosine of 50 degrees, comma, sine of 50 degrees. And then use a calculator to work it out. And for point Q, remember cosine is always x, sine is always y. Cosine 110 degrees, sine 110 degrees. And use a calculator to work that out. Also use this calculator. Make sure you're calculating degree mode, by the way. And we are going to talk about radians today. That's a new measurement. So that's 0.642, comma, sine of 50, 0.766. That kind of makes sense because both x and y are positive where point P is located, right? And it seems like y is a tad higher than x. And then cosine 110, that should be negative, which it is, negative 0.342. That makes sense. Comma, sine 110, which is 0.940, which is kind of high, as it should be, because it is kind of close to 1. So that's all very simple, right? Now for 755, remember the radius is 1. You're told that, right? You're told OR is 1. And it rotates, well, we got to figure out how much OR rotates. So this little like circle thing in the middle, it's not full revolution, right? It almost does a full revolution, but it stops short by how much? 60 degrees. So you simply do 360 minus 60. That's all. Because if this is 60 degrees right here, right? Then this, the rotation is 360 minus 60, which is 300 degrees. Another way you could think of it too, which I kind of explained during class the other day, is you could think, or yesterday actually, you could think of it like this, like, okay, well, I go 90, 90, 90, and an extra 30 to get to where OR is. So that works too. 90 plus 90 plus 90 plus 30 is 300. Then what are the exact values of OS and SR? Well, that's where you can use the 30, 60, 90 ratio, right? You should know this, right? If that's 1, and that's 60 degrees, you should know that's root 3 over 2, and that's 1/2. And there you go. So OS is 1/2, SR is root 3 over 2. And the coordinates of point R, well, the X is positive, right? But the Y is negative because you're in the 4th quadrant. So it's like that. Does that make sense? How I got 75? We're good? Okay. Let me save that as a PDF. There we go. All right, now let's look at these problems here. They say, what angle in the first quadrant could you reference to help you find sine cosine? So what they're asking for here is see how far this is from the x-axis. So basically what you're looking for is looking for an acute angle between the given measurement. Who's yelling? Okay. Oh, geez. Okay, someone sounds frustrated. So it's the acute angle between the given measurement and the x-axis. What does acute mean? You guys remember? Yeah, less than 90, exactly right. So 330 looks like this. Think of the screamer ride, right? So 330 looks like this. Oh, geez. All right, okay. So how far is 330 from the x-axis? 30 degrees, exact. So that's called a reference angle. 120 is like that, right? How far is that away from the x-axis? What would be the acute angle there? We'd say 60 degrees. 60 degrees, right? 113. That'd be 67 degrees. So we call these reference angles because you're referencing something in the first quadrant. And then 203, that'd be 23 degrees, exactly right. So it's not hard if you just draw and visualize. That's really what you're doing. It's not a formulaic thing because it could change every time. Like the case of D, I subtract 180. But in case of A, I did 360 minus 30. In the case of these here, I did 180 minus each of these. So she do 180 minus or 360 minus or the angle minus 180. I don't want you to get to memorize because you'll drive yourself nuts. The best thing to do is understand that a reference angle is an angle that's referenced to the first quadrant. So you're just looking for an acute angle between the given measurement and the x-axis. What's the quickest way to get to the x-axis? Whether you go to the negative or positive side of it doesn't matter. Just got to get there as quickly as possible. And we use this to help us with evaluating trig functions of various angles later on, which we're going to do on Monday. Okay, 757, we want to do for this one is update the equation. Let's say update, like change the base of one of the base, or change the base of one of the powers. So 1/8, I know I can make 1/2, right? I know this. So it's 1/2 cubed. That's 2x minus 3 equals 1/2 x plus 2. So now, how do I rewrite it? I do 1/2 6x minus 9. Oh, geez, sorry. Equals 1/2 x plus 2. Since those are the same, those are the same. Does that make sense? You guys see how I changed the 1/8? Does that make sense? Because 2 cubed is 8, right? Even if it's a fraction, you can still change it the same way. Just change the denominator from 8 to 2 cubed. Same thing. So 6x minus 9 equals x plus 2. 5x equals 11. X is 11/5. Okay, so there we go for that one. For 62. Her C was 53 horizontal feet from the central support pole. What was her seat's angle of rotation? So really, you're just drawing a triangle like this. What was the radius of the screamer ride? You guys remember? 100. And that's 53. And I'll call it theta. How do I solve for theta? What would I do? Yeah, you can do a cosine. Cosine 53 over 100. So theta would be the inverse cosine of 0.53. And then use your calculator to work it out. That should be 0.53. You get 58 degrees. For 763, sketch a unit circle, blah, blah, blah. So I'll just do this. Let me switch colors to dark blue. And we're just going to label on the unit circle all the different parts. So x is positive, y is negative. Where would that be, would you say? Would it be in the first quadrant? So, and actually, let me label the quadrants as well. Yeah, totally. Yep. Yeah, that's how you label the quadrants. Yeah, totally agree. So I'll just put somewhere here. Call it A. Okay, let me kind of figure out these other ones. So here, y equals -1. Here, x is negative, y is negative. And here, that's x, and that's y. So let's look at part B. So probably right here, right? Part C, probably right here. And part A, probably over here. Sorry, part D, my bad. Part D would be over there. Does that make sense? We're gonna ask a question like this on the test. Just so you know. So this is a test question. Because we want to make sure you're understanding how unit circle works. So, does that make sense? Remember, cosines x, sines y. And could an angle have a sine of 0.9 and 0.8? The answer is no. That's because x squared plus y squared equals 1. Remember, x is 0.8. That's cosine. Ah, geez. That's sloppy. Did I make a mistake? Oh, you're right. Yes. Thank you. You're 100% correct. It's right here. Thank you, Hunter. I didn't see a negative there. Yeah. So going back to part E, that's not going to work because I get 0.64 plus 0.81. So 1.45 does not equal 1. So oh, let me save this. Here we go. Okay. Now to home stretch here. Let me zoom out a tad, clear it. Okay. Approximate the coordinates of point R. So that's going to be the cosine of 70 degrees, comma the sine of 70 degrees. Which is 0.342. And sine 70, which is 0.94. Can we just have that earlier? Oh, I guess it's some of the 110. Okay. I knew that looked familiar. Okay. So that's what you get for that one. So then for part B, how would you express the exact coordinates? You leave it in trig form. And that's kind of a lead to part C. For part C, show that the Pythagorean identity works. So the Pythagorean identity just means sine squared theta plus cosine squared theta. But when you square a trig function, you can put next to the function itself. It's the same thing as putting parentheses around it. Equals 1. So if you think about it, cosine 70 degrees squared, because that's x, right? Because again, we're doing x squared plus y squared equals 1. I just showed that in the previous problem for part E. Squared plus sine 70 degrees squared equals 1 squared. So if I do 0.342 squared plus 0.94 squared, so 0.117 plus 0.94 squared, which is 0.884 or 0.883, we'll say. All that equals 1. So it makes sense. Because again, Pythagorean theorem is going to work here because that's x, that's y, and that's 1, right? And that's the equation of a circle, by the way. That has a radius of 1 and a center at 0, 0. And lastly, y equals sine theta. That's going to correspond to graph 2. That corresponds to graph 1. That's because sine starts at the origin, whereas cosine starts at 0, 1. And shifted by 90 degrees, by the way. Okay, any questions? No? Okay, cool. I saved all those. I'll put those to School-G. And also there's a recording here. So if you guys can now move on to your notes, let's get that out of the way today. There's an activity. I'm just going to kind of tell you what's up with radians. And we'll do some examples next page, and homework will be super short. Looks like just 5 problems total. Okay, so let me explain what a radian is. Don't worry about all those mumbo jumbo. I got my way of explaining to you guys that I like. Okay. First off, you may want to do this off to the side, maybe find a little corner or something. Because we kind of need to have this discussion so you guys understand what a radian is. Let's say you have a circle. This was a text box, probably better. Okay, so this is 90 degrees, right? Let me switch colors, sorry. And say it's 2 and 2. You guys remember the form for circumference? What's the form for circumference? You guys remember? No? Close, 2 pi r. What's pi r squared? What would that be for the circle? What would that represent? Area, exactly. Area is always squared. Circumference is circle distance. Like if you went to the track out here by the field house, with the football field, I mean, it's not circular, but assume it is. You walk around it, that would be the perimeter of a circle, right? So 2 pi r. So you would take the radius of the circle, multiply by 2 pi, that would get you the distance you walked around or ran around. Now, for this particular circle, my circumference is 4 pi, right? So what would be the length of this arc? I'll highlight in yellow. Yeah, 4 pi is the distance around the circle.
If you had to raise it to. So what would be I know it's RC, but what would be this arc right here, this arc length, this distance? What would that value be? What do you guys think? If the whole thing is 4 pi, one. Thank you, 1 pi.
That's gonna be 1 pi. Because think about it. The arc is pi because 90 degrees is 1/4 of what angle? 360. What does 360 represent? If you do 360, what does that represent? A full circle.
Am I doing a full circle, just yellow highlighting? No. What fraction circle did I do? And how's that determined? By the central angle, right? The central angle is 90, right? 90 over 360 is 1/4.
So instead of doing formulas, I think it's kind of crazy. Just understand it. Like, hey, I got 1/4 of the circle highlighted. So great. What's 1/4 of the circumference? Fine, done. And why is 1/4 again? Because you have 90 degrees central angle. Okay. So hopefully that makes sense. If you want a formula, fine. Here's the formula. The formula would be this. Your central angle divide by 360 times 2 pi r. But you just understand it, right? Like,
yeah, about 90. What's 90 over 360 reduced to 1/4? What's 1/4 of the circumference? My circumference is 4 pi, 1/4 that's pi. That's all.
So hopefully, does that make sense before I do this discussion on radians? Oh, good.
Arc length. Yeah, sorry. Sorry.
I should have typed that up. Arc length. Yeah. Because that's the length of the arc. Right. Yeah. Sorry about that. Okay. Monty, you have a question? 4 pi. Yeah. Let me do this. Hold on. Let me just type it up. It's probably better. So C equals 2 pi r, 2 times pi, which equals 4 times pi. And again, arc length is pi, since 90 degrees is 1/4 of 360 degrees. Hope that helps. Is that better? Yep. Okay. And let me just resize that a little bit. Okay, we're cool. Okay. Now, here's the actual part I care about, guys. Part I actually care about. This right here. Excuse me. Excuse me. Oh, must be spring. Here we go. Okay. Let's have 2 and 2 again, right? Now remember, this was pi down here, right? And what's pi roughly as a number? You guys should know this.
3.141.
We had pi day, right, last week. Actually, a week ago from today, right?
Now, I reduced this angle a little bit, right? It's not quite 90. Maybe it's 50 or 60. I won't tell you what it is exactly yet. And this arc here, is it possible
that this arc can equal 2? Sure. Why not? Right? Of course the arc. So basically, can the arc equal its radius? Yes, it totally can. In fact, actually, let me write some more general terms. So this is R. This is R. So even though you wrote 2, if you could change that to R, I prefer that. You'll see why in just a little bit. And this curved part, I'm going to call R as well. Okay? Cool. Now, I'll call this theta. When this happens, when the arc length is the same numerical value as the radius, the central angle has a measure of 1 radian. Okay? That is very important.
It helps you understand what a radian is. So when arc length has the same numerical value as the radius, the central angle, right, the angle for the center, because it's the vertex at the center,
Has a measure of 1 radian. Okay? So that's called 1 radian. That's the definition of 1 radian. That right there. Bless you. Now let me erase the other stuff because we don't need any more. So I need some space. So now we're going to do some proportional reasoning. We're going to look at theta over 360 degrees r over 2 pi r. Remember, this is a full circle. You'll see in a sec.
Does that make sense why we're doing this? Because doesn't theta correspond to R, right? So when you do ratios, you always do things that correspond to each other. Doesn't theta correspond to R? Doesn't 360 correspond to 2 pi r? Right? Isn't 360 a full circle, circumference full circle? This arc was determined by this angle, right?
So just like when you had one of the homework problems you just had, right? With a 3.5, there's like 2 homeworks ago. Yeah, 3.5 foot posts, right? Or say this is 3 and 4. And say this is like 6 and 8. Does that, that's, when you have similar triangles, right? You do proportional reasoning. That's exactly what I'm doing here. That's exactly what I'm doing. So the theta, I'm going to change to 1 radian. Because that's what it is now. It equals 1 radian. Theta equals 1 radian. If I cross multiply, here's what's going to happen. If I cross multiply, I get 2 pi r times 1 radian equals r times 360 degrees. What happens to r's on each side? What can you do with the r's on each side? Cancel. What are you stuck with? 2 pi radians equals 360 degrees. And that is what a radian is. That's how you convert it. A full circle, 360 degrees, is also the same thing as 2 pi radians.
By virtue of this proportional that I just saw, right? So 360 degrees times r, 2 pi r times 1 radian. And this makes sense because that would part of a circle, the whole, part to whole. You guys know what I mean? Part to whole, part to whole, part to whole, right? And it's the same part, right? This part turns this part, but this whole turns this whole. Cross multiply, we're good. We got this.
2 pi radians equals 360 degrees. Okay. So now we'll move on. And also another way to think of this too. you can reduce it. Pi radians equals 180 degrees. That works too. Pi radians equals 180 degrees. Okay. So I just said it right now, 1 equals pi radians. Or, I don't know what they mean by or. I know this is true. Yeah, I'm not sure what's meant by this or thing. Yeah, I don't know what that means. I'm gonna cross this off, guys. I have no idea what that means. The conversion is this, though. To go from degrees to radians, you take your angle and you multiply by pi over 180 degrees. And to go the other way around from radians to degrees, you take your angle and you multiply by that. By the way, if you don't see a symbol, let me write the text box. If an angle doesn't show a degree symbol, you must assume that the measure is given in radians. That's the default, especially as you guys move on to pre-calculus. That's what we do, and especially in calculus, that's totally the assumption. We always assume that. If an angle doesn't show, so notice how this angle, I don't show a degree symbol, so you assume it's radians. You go from radians to degrees, and you need to cancel, and you get times 180 or the other way around. So we're gonna do some conversions right now. You'll see in action right now. So I want to convert 36 degrees to radians. To do this. And then you do this. And you work out each case. I think that's 3 pi over 2. That's 16 over 9 pi. And that I think is pi over 5. You can give it decimals you want, but I think just in terms of pi is fine. Pi over 5. 16 pi over 9. Yeah, totally. 100%. Yeah, 100%. Yeah. 3 pi over 2. Yeah, and you can, do you guys know how to reduce fractions in the calculator? Yes, no? I'll show you guys. Really easy. So if I do 36 over 180, hit math, and then frac, it converts to a fraction for you. Or 320 over 180, hit math, and frac, 689. Or 270 over 180, hit math, the first off and frac, 3/2. And of course, put the pi at the end. Okay, well, last one. We're all done. We're gonna go the other way around now. So now we're gonna flip. Pi over 15 times 180 over pi. Two pi over 3. Yeah, they will. Yes, they will. Yes. And 8 pi over 30 Now, just because you see a pi doesn't automatically assume it's radians. If I did this here, that's degrees. I wouldn't do that. It's kind of weird. Just so you don't see, but radians could be also like this, like 1/4 radian. You don't have to have a pi. Like we talked about 1 radian, right? There doesn't have to be a pi there. Usually there is. There doesn't have to be a pi there. So don't fret if you don't see a pi. It could still be radians. But fortunately, these all cancel, right? So what's that going to be? 12 degrees, I think. Yeah, there's a little degree symbol. Sorry, I forgot to do that. That's going to be 120 degrees, I think. And what's that going to be? 648 degrees. All right, we're good? Cool. Okay. Good. All right, so we're all done. Promise we be done early. We get at what, 2:05? Is that correct?
Yeah.
Yeah. So you totally can knock this homework out and have no math homework for the weekend. I would strongly suggest you do that. Yeah, it would totally. And you can watch March Madness.